Subscribe to Tech Talks and hit the bell icon to get notifications about coolest and latest engineering technology in the first place. To solve this numerical, we will first draw the diagram. So it is given 2 kilometer long line and it supplies a load of 120 ampere at 0.8 power factor lagging at the far end. So in the far end we name it as A. It is supplying a load of 120 ampere 0.8 pf lagging and a load of 80 ampere 0.9 pf lagging at its midpoint. So this is the midpoint B. Here it is supplying a load of 80 ampere 0.9 pf lagging. Both pfs are referred to the voltage at the far end. Impedance is 0.05 plus j 0.1 ohm per kilometer. It is a 2 kilometer long line, so this is 1 kilometer and this is 1 kilometer. It means that this is 1 kilometer and this is 1 kilometer, and the impedance over here is 0.05 plus j 0.1 ohm, and here also same 0.05 plus j 0.1 ohm. And if the voltage at the far end, that means at this end, is maintained at 230 volt, it is maintained at 230 volt, calculate voltage in the sending end. This is the sending end, let us name it as O. This is the sending end voltage. Sending end voltage. So the voltage at this end, we have to find out what is the voltage at this end. Phase angle between voltages at two ends, that is voltages at point O and A, what is the voltage, and we also have to draw the phasor diagram. So how we will start this one? Okay, so before starting this one, we will first convert these values to polar form. Okay, so 0.8 pf lag, that is cos inverse of 0.8 is 36.869, almost 36.87. So current is this at this point is 120 at an angle of minus 36.87 degree ampere, and cos inverse of 0.9 is 25.84. So current in this end is 80 at an angle of minus 25.84 degree. Why minus? Because the power factor is lagging. Simple thing is that power factor is lagging. Okay. Now another information is given over here, that is voltage in the far end is 230 volt. So voltage at this end is 230 volt. We will also mark it as VA is equal to 230 at an angle 0 degree voltage. That's the current. So let us now name it. Let us name it that this is current I1. This is current I1 and this is current I2. Now let us draw some table over here. So we will be distinguishing it in two parts, separating it in two parts. One is part BA, that is transmission line B to A. Another is from O to B. Okay, and we will find out what is the Z over there. Z, impedance Z. Okay, so Z over here is 0.05 plus J 0.1. We will convert this one to polar form. Why we will convert this one to polar form? That is because at the end we have to draw a phasor diagram. So if we convert it to polar form from the very beginning, it will be very easy for us to draw the phasor diagram. So it is coming as 0.111 at an angle of 63.43. ohm. Since the values are same, so here also it will be same, that is 0.111 at an angle of 63.43 degree ohm. Now next we will find out that what are the current in these branches, So in BA, this branch, the current is this one only, I1. So what is this current? This current is 120 at an angle of minus 36.87 degree ampere. And current in this branch, that is OB, this current is equal to what? This current is equal to current in this branch, that is this much of current, and current in this branch, that is this current. So this is equal to 80 at an angle of minus 25.84 degree plus 120 at an angle of minus 36.87 degree. That is 80 at an angle of minus 25.84 plus 120 at an angle of minus 36.87. It is coming as 199.11 at an angle of minus 32.46 degree ampere. So this is the current BA and this is the current OB. Okay. Next what we will do, then we will find out the voltages in this branch and this branch. So what will be the voltage? The voltage in this branch will be multiplication of these two, because this is the current in AB branch and this is the impedance of AB branch. So voltage in this branch will be multiplication of these two. So let us do 120 at an angle of minus 36.87 plus 0.111 at an angle of 63.43. So it is coming as what? Sorry, this will be multiplication. It is 13.32 at an angle of 26.56. 26.56 volt, and the voltage in this branch will be multiplication of this voltage, this impedance, and this current. So let us do that also. So this current is what? 199 at an angle of minus 32.46. Minus 32.46 into remaining. So this comes out as 22.09 at an angle of 30.97 degree voltage. Okay. Now what will be the voltage? Now this is over. In this type of sum, you just have to prepare this type of table. If you prepare this type of table, it will be very easy for you to remember and very easy to solve the problem. Now the next thing is what? The next thing is to find out the sending end voltage. Voltage at this end. So the sending end voltage will be what? Let's name it as Vs. The sending end voltage. This voltage will be what? This voltage will be voltage of OB plus voltage of BA plus voltage at this point, that is VA. Okay. Now we have to just put values and we have to calculate that what is the voltage. VOB, it is 2.09 at an angle of 30.97 plus 13.32 at an angle of 26.56 plus VA 230 at an angle of 0. We'll convert this one to polar form. It is coming as 261.43 at an angle of 3.7978 volts. This type of sum, if you do using this tabular form, you will be there is no requirement to remember any formula. This is just an application of circuit theory. It will be seems easy to remember. And you'll see when the next trick is that I have converted everything to polar form. Since I have converted everything to polar form, these two answers, that is the voltage in the sending end, we have directly got it as 261.43, and phase angle between voltage at two ends, this will be 3.8, because voltage in the receiving end we have taken as 0, and Vs, that is this voltage, is 3. It is angle at 3.8 degree. So whatever phase angle between the voltage as two ends is required, we have already got the answer. Now comes the phasor. Now I have done all these things in polar form because it will help us in understanding the phasor. So we will try to draw the phasor from this point, that is voltage, this voltage, the receiving end voltage. So this is V, This is VA. Now the current here is 36.87 degree lagging 120. So this will be our I1. The angle over here will be 36.87 degree. Okay. Now the next thing is that if this one is I1, so this one will be I1 R1 and this one will be I1 X1, J I1 X1. This will be 90 degree. So this will be our voltage. This voltage is which voltage? This voltage is voltage at point B. This is voltage at point B. Okay. If you want to know more about phasor diagram, you can see one of my video. I will be giving the link in the description box. Also, you can click the symbol in the upper part of your screen. Okay. Now moving on. So this is I1. Next we will be doing what? Next I2. I2 is where? I2 is minus 25.84. So minus 25 is less than 36. Right? So it will be somewhere here. This angle will be 25.84 degree. So this is 25.84. So this will be I2R and this will be J I2X and if we add up this phasor, this will be our VO or receiving end voltage, VS. Sorry, sending end voltage, VS. Okay. Now the question is, which angle is 3.8? The angle between VA and VS, that is this angle. This angle is 3.8 degree. Okay. Comment below about how you like this video. Check out the links in the description box about more such videos. Do click the like button if you like the video. If you are new to this channel, subscribe Tech Talks and don't forget to hit the bell icon.